In part 1, we built the layout for our new MacroPad. Now we need to turn that into a circuit board that we can order from an online supplier. Fortunately for us, having a custom circuit board fabricated is way easier than it sounds, and the board we're trying to design is about as simple as it gets. I'm not going to teach you everything there is to know about KiCad, partly because I don't know much, but we can get through the basics together. We could create the physical layout of the key switches on our PCB, but since we already have a layout, we're going to use a web tool to do that for us. keyboardtools.xyz is linked from the MacroPad resource page, and it takes a keyboard layout editor file and turns it into a KiCad project. The only thing we need to change here is we are using hot swap switches, so change that over. Defaults are fine for the rest of it, and we'll upload our JSON file from Keyboard Layout Editor. Give it a few minutes to think, and you should see a familiar looking layout pop up here as a circuit board. Down at the bottom, we'll download the project as a zip file, and then unzip that somewhere convenient with its keyboard and logs folder. Now we're going to need KiCad, which is also linked from the resource page. We'll download that, run the installer. Defaults are fine for everything. Once KiCad is ready to go, finish it. We'll select Start with Default Settings, and we're fine with sending data collection. We're not going to check for updates though. Alright, go to File, Open Project, and in the folder with your MacroPad files you just downloaded, find the keyboard folder, and the keyboard.kicad pro project file. This just opens a small list of files here. The only one we care about right now is KiCad PCB. Double-click that, you get a question. If you're not sure which option to select, use the default. Sounds good to me. This will take a couple minutes. Alright, what are we looking at here? Well, obviously we've got the outline of a printed circuit board, and we've got outlines for a whole bunch of components. We have shapes approximating key caps, the key switches themselves. We got some light blue holes here for the hot swap sockets and the key switch itself. And we've got diodes placed down, which will be an important part of our keyboard matrix that we'll talk about in a minute. All of the objects shown here are in a specific layer, and we're going to turn some of them off so it's not quite so cluttered. Over here on the right, under the Layers list, we can turn off User Drawings. That's the outline of the keycaps. And we'll also turn off Front Fab and Back Fab, which both add additional info about the components that won't actually go on the circuit board. In addition to the key switches and the diodes, we also have one other component that the layout generator helpfully added for us, which is spots for stabilizers for the 2U keys. I'm not actually going to use stabilizers in my design, so I want to get rid of them. If I click here, KiCad says there's two things here you could select, the stabilizer, ST4, or the switch. I'm going to select the stabilizer. Hold down Control to select the others, and if I click on the part of the footprint that's just for the stabilizer, I don't have to tell it each time. Select all of those and hit Delete. When you're zooming around your circuit board, it may take you a minute to realize when you mouse wheel zoom in, it zooms into where the cursor is. This can take a little bit to get used to, but once you're used to it, it means you don't really have to mouse wheel drag around. You can just mouse wheel zoom in. Hit the home key at any time to go back to the overview of the board. In addition to the holes and the key switches, another thing we can see on the screen are these dark blue pads. If we double click on one of them, we see two important things in its properties window: a pad number, the text that shows up on the first line, and a net name. Now, nets are how KiCad understands electrical circuits. Each pad is assigned to a net, and that determines which other pads it should be connected to. So if we look at this N$1 net here, KiCad has helpfully drawn a little ghost line down to the other N$1 pad on this diode. So that's a helpful suggestion that you might want to think about connecting those two pads with a trace. And we'll do that in just a minute. The other nuts we'll see here are named column 0, row 0. Those are pretty straightforward. We have row 1, row 2, and row 3. Now if we go across the columns, we have column 0, column 1, column 2, and surprisingly, column 4. I think the layout generator had a little bit of an issue with the 2U space here. So I'm going to open this up by double-clicking it and set it to col 3. I'll just create a net for that. Now, if you have any background with KiCad, you may be surprised that we're not doing this in the schematic editor. This particular layout generator doesn't create a schematic for our circuit. We're just working with the netlist that it provided. If you were doing a more complex circuit, you probably would want to build the schematic view and drive everything from there, but this way works just fine for a simple circuit. All right, following these little ghost lines here, called the rat's nest, we want to actually connect the column 0 pads together. To do that, we're going to use a tool called trace. And when we hit X to activate the trace tool, it's actually going to start a trace wherever the mouse cursor is. So we'll hover over the pad, and it helpfully selects the other pads that we might want to connect here. And in fact, we're going to drag down to this one and click to create a trace. Click again, drag down, and we've connected all of the column 0 pads. We're going to do the same thing here, except we'll speed it up a little bit by dragging through this pad onto the next one, and then to the final one here. You'll notice that the trace kind of tries to follow your mouse cursor. If you move over from here, it's going to route the diagonal line around, but if you mouse over the pads that you want to connect, you can just click to route all of them at once. Column 2 is easy, they're all in a line. And column 3 finishes out the columns. Well, it's going pretty fast. We can do the same thing with the rows, which have smaller labels, but you can see them labeled here on the diodes. We'll click here, drag across to the next one, and KiCad seems to be trying to take a shortcut. We want to go, yeah, it doesn't want to go across there. Well, there's already a trace in the way. Remember, our column trace went from there to there. And on a two-dimensional board, we can't just jump over that other trace. But our board is not strictly two-dimensional. It's actually 2 layers. Right now we're drawing traces on the back layer of the board, where the diodes are going to sit. But if we hit the V key and click, we flip over into the shadow realm. Actually, it's the front side of the board. That's what the red color means. You can look over at the layer list here to see that the front copper layer is in red. And our red trace can happily cross our blue trace. We do need to get back to the blue world to get to our diode, so we'll hit V and click again, and then we can get to our pad. Click to start another trace, V click to go over, V click to come back, and we'll connect our diode. The vias are placed on the grid, by the way, which is why you see them snapping to odd places. You can change your grid size here if you want to line things up exactly. I'm not going to bother right at the moment. I'm not going for any design awards here. And these vias will work just fine. We're going to go and connect the rest of the rows. If you make a mistake, hit Ctrl-Z at any time. If you're still drawing the trace when you hit Ctrl-Z, it'll take you back to the last point that you clicked, so you can re-click it. V, click, V, click. So what are we doing with all of these rows and columns anyway? Well, a very simple MacroPad like this one, with only 15 switches, would easily fit on our C Picro, which has 24 I/O pins available. Each switch could use a single I/O pin and connect it to ground. If you get much larger than that, though, you start running out of I/O pins really fast, and you either use I/O expanders or more microcontrollers. A better way to do it is to use a keyboard matrix. There's a link on the MacroPad resource page if you're interested in more details. Down here under Sources, how a keyboard matrix works. But the basic idea is that having the microcontroller send voltage down the columns and then detect which row the voltage comes out, it can scan through 15 key switches using only 8 I/O pins, 4 rows and 4 columns. With the 24 I/O pins on our microcontroller, this can scale all the way up to 12 by 12 or 144 keys. This is how larger keyboards are built, and it means the same exact system can scale up as far as you want, pretty much. I just built an 84-key keyboard using the same method. So that's our rows and columns connected. If you notice the little ghost lines here, you'll see that we still need to connect our key switches, hot swap sockets, to the diodes. So add a little trace from key switch pad to the diode pad. All right, all the little ghost lines are gone, so our circuit must be done, right? Well, unfortunately, it doesn't connect to a whole lot. We are missing the brains of the operation. On the board, I mean. We need to add a footprint for a symbol that's not in KiCad, but fortunately there's footprint libraries available online. We're going to go here to Tools, Footprint Editor. This is the first time you run it, it'll take a minute. Preferences, Manage Footprint Libraries, and then hit the folder icon down here to add a new footprint library. Back on the resource page, under Downloads, we're going to go to the Picro footprint library provided by the designer of the Picro. Click the green code button here and download zip. Unzip this to your project folder so we can find it later. And then in the footprint editor, we'll go to the Picro footprints main folder, and then the Picro folder inside of it, and hit select folder. All right, now we can see our Picro library down here. We'll hit OK on this, let it think for a minute, close the footprint editor, and now we can use the Add Footprint tool over here on the right to add a new Picro. And we'll type Picro in the list here in the filter. And we should see 8 different footprints for the Picro, depending on which version and mounting type you want. We're looking for the Picro EXT, through-hole mounted, flipped. That means, as it says on the silkscreen here, the components on the Picro board are going to be facing down toward our PCB. That's going to minimize the amount of space that it takes up and sandwich the USB-C port between this board and our PCB. So hit OK to select that, and we have a Picro stuck to our cursor. Hit the R key, you can rotate it, and we're going to line it up approximately with our board edge here, because we want our USB-C port along the edge. Now we need to do some redrawing here. Obviously our circuit board is not big enough to have the Picro on it. If you use a smaller microprocessor, sometimes you can fit it in between the key switches, especially if you have a spacebar or something on a larger keyboard. But our Picro is going to hang out right here. Let's make some more room on the drawing page. We can hit Control-A to select everything. Hit Escape first to go back to the default tool. Control-A and drag to put everything on the page. And now we need to make some room for our Picro. The board edge that we looked at earlier is over here on the edge cuts layer, and we can just move these lines around where we want them to be. Now when I'm moving the board edge, I like having the grid set to 1 millimeter so that everything snaps to nice round numbers. So let's do that, and we can just drag this edge up to about where we want it to be. We're going to have a nice rounded corner here, so we don't want to cut it too close. Speaking of corners, the layout generator gave us these line segments to make the corners. We're going to turn those into actual arcs. I don't know if you'd notice the difference at the scale this is going to be, but I would rather see nice round arcs here, and it'll make it simpler when we're designing the case later. I'm just dragging a box around the line segments and hitting delete. Now, to make this a nice rounded rectangle, unfortunately KiCad doesn't have a lot of drawing tools available, but we're going to use what we can. With this 1mm grid selected, we're going to drag this edge to snap it to a grid line. And we're going to double click it just to check. X is 31. I think the endpoints, the Y is not quite set yet. So you can drag those to give it nice sharp corners. You may notice that the line doesn't stay vertical though. Fix that by hitting Shift Space while you're dragging, and now it'll stay nice and vertical or horizontal. So we'll drag these corners out until they meet. And that'll give us a guide point for where we're going to put our corner arcs. If you have trouble getting them to snap together, like this one, grab the line, hit N to move. And as soon as you move it, it's going to snap to the grid points again. Home goes back to the overview. Connect this one. And there's our board with nice sharp outlines. We'll move our Picro over, hit M. Yeah, that's actually a pretty good spot there. All right, to put our corner arcs on, we're going to go over here to the drawing tools and draw an arc. We want to make sure that the edge cuts layer is selected on the list here, so that's what we're drawing. We're going to start our arc on the sharp corner of the board with a click, and then we'll drag out to the radius that we want. We want to drag horizontally, by the way. If you don't have Shift Space Snap on, you can turn that on. We'll drag out horizontally to, let's go 5mm for the rounded corners. Click once to set the starting point, and then click again to set the ending point. And there's our arc. We can hit the Move key, and we'll use the arrow keys to move it down 5 and over 5. And there's a rounded corner for the board. You will notice it's not the same line width as the board. As far as I know, that's just a visual thing, but we'll go in here and change this to 0.4. All right, that looks good. I can drag these points back 5mm to connect to the arc. We'll duplicate this arc for the other corners. Select it and hit Ctrl D to get a copy. Hit R to rotate it down to the bottom left, and we'll stick it in our bottom left corner. We apparently didn't move our bottom edge to be on the grid, so select it, hit M, and it immediately snaps to the grid. We can just click to drop it. We'll connect the endpoints here, and duplicate it again. Ctrl D, R. Be careful when you rotate it, by the way. You want to make sure you have your cursor over one of the endpoints. Otherwise, you can wind up rotating from the middle of the arc, which gets it off the grid. For example, if I went to duplicate this arc and I picked a point in the middle and hit Ctrl D, it's now stuck to the middle of the cursor. And when I rotate it, it may or may not be on the grid anymore. So if I click on the end point of the arc and hit Ctrl D and rotate, should be in the right position to fit right here, just like that. We'll connect these line segments. Hit Home to go back to the board overview, and we've got a lovely rounded edge on our circuit board. All right, before we start routing anything for the Picro, we're going to make sure our board is actually laid out the way we think it is. Let's go up here to 3D Viewer, or Alt-3, and we'll see a picture of our board. And it's pretty easy to see which side of the board things are on. You can left-click drag to rotate, or just hit F to flip the board over. So on the back side of the board, we can see our diodes, where they should be. We see the pads, where the key switch sockets are going to be. And we see the header pins for the Picro, but it's on the front side of the board. There's no reason we couldn't do that, but it would make our enclosure a little bit different, and we'd need to allow room for the Picro to sit up here. I'd rather have it on the back side. So go back to the PCB viewer. We'll double click on the Picro. Don't click on any of the pads, just click on the space in the middle. And down here under position, we're going to set its side to back side of the circuit board. And KiCad hopefully flips it for us, so we'll hit R twice to get it back around the way we want it. All right, component side down, just like we want. We go back to the 3D viewer. We now see the Picro would sit on top of the plastic part of the header pins right here, just where we wanted it. All right, for routing the Picro, we zoom in on this, each of the pads has numbers. Unfortunately, this particular footprint, these numbers are completely meaningless. I don't know if this is a normal thing in KiCad or if it's just an issue with this particular footprint, but we really need to see the Picro pinout so we can figure out what we're wiring here. We go back here to the MacroPad resource page. Under reference, we have a Picro pinout. That's what we really need right now. So, on the left side of the USB socket, we have a pin for the USB. We don't care about that. And then we have GPIO pins. 0 and 1 are here, 2 ground pins, and then a bunch of GPIO pins. Come back to KiCad, we can see data pin here, 2 GPIO pins, and then we can confirm that these 2 square pads here are ground pins, and then GPIO pins going down this way. Now, the footprint being on the back side of the board, yes, it's on the back side of the board, but it's also flipped, right? We're putting the Picro on upside down. So we're actually looking at the Picro in the same orientation, right? We're looking through the circuit board at the component side of the Picro. So we want to wire our columns and rows to 8 of the GPIO pins. And the ones I like are right here, because there's 8 of them. So we could use 2, 3, 4, 5, 6, 7, 8, 9. We don't care about any of the other capabilities of these pins. I'm just picking these because they're on this side. Again, though, remember we need these names for the pads. So after our 2 square ground pins, we're going to start numbering with 2 through 9. And if we double click on a pad, we can edit its properties so that we remember what this is. I'm going to call this GP2 for general purpose 2, because that's what the firmware calls this pin when we get to that point. It doesn't have a net assigned because our layout generator didn't know about these pins, but I want to connect this to column 0. Type that or select it from the list here. We'll hit OK, and KiCad added it to the rat's nest so we can see where it should be routed. We'll repeat that for the other pads. If you're having trouble just selecting the pad, by the way, if I click here, I get the footprint itself. Down here in the selection filter, you can uncheck all items and just check pads. Now when you click on something, KiCad is only looking for pads. Just don't forget to change that later when you want to select something else. I'm going to go through all of these and give them names. This is GP3, and connect them to existing nets. You can actually connect them in any order that you want. The firmware doesn't care. But this is, I think, a sensible order for this layout. We'll go column 0 through 3, and then row 0 through 3. And then the last pin on this side should be GP9. And we'll connect it to row 3. We're going to go back to our pinout real quick and just make sure, yep, GP9 is the last pin on that side. So those are going to be the 8 I/O pins that we want to use. Now, we just have to figure out how to untangle this rat's nest to get them connected to the row and column pins. So this first one will be easy. We'll hover over the pad, hit X, and we're drawing on the front side by default for some reason, even though this pad here is on the back side. So I actually want to start the trace from here. And we'll draw on the back side to get to this pad. These pads are on the front and back side because they're through-hole. They're plated on both sides, so it doesn't matter which side we use to connect to them. And it defaults to the front, so I'm going to start the trace from here. And I'm going to try to stay out of the way of all of the other traces that I know are going to come. I can set an intermediate point by clicking here, and then move up to where I want to finish the trace. All right, column 2. Come up here. And sometimes that intermediate point is pretty helpful. Otherwise it gets a little crazy. Oh, the other thing messing me up is the grid size. I can change this grid size down to 0.2 or something more suitable for routing traces. If I want to undo that last point, I just hit Control Z. Column 3, we'll finish this out. I'm being all kinds of weird tonight. There we go. And now we're on to the rows. The rat's nest line will actually draw a line to the closest point where you could connect it. So row 0 here is actually not on any of the pads, it's at the via. And that's a perfectly legitimate place to connect this trace. Since we have 3 backside traces to get under, we are going to draw on the front side of the board. Go from here on the red layer down here. Vias also are on both sides of the board because that's what they do. They connect the front layer to the back layer. Our next couple of rows, KiCad draws straight down through here, but that looks a little crowded to me. So I'm going to go over this way because it doesn't actually matter where you connect the trace to the row. Notice that I'm going along the blue side here because I can't cross the red side. Then I'll connect it to this via here. This seems like a good pattern, so we'll do this for the next row. All the way down here. And the final row, which can go the long way. Do that a little bit. Bring it down to here. Oh, it's not going to connect there. It'll draw the line there, but that diode's on the back side of the board, and we're currently on the front side of the board. So we'll hit V, click to make a via, and now we can connect to that pad. This is looking pretty good. One thing that we're still missing for the C Picro is a reset button. That is how you put it in bootloader mode to flash the firmware. It's not strictly required. You could short the reset pin to ground without using a button for that, but we're going to add a button here. So we'll go back to Add Footprint, and there's lots of switches in the library. The one I want to use is 1187 because that is a part in JLCPCB's library, and they will assemble it for you if you use that footprint. Now, I would like this to be centered on the board, but there's no snapping feature here. So we're just going to drop it approximately there. Hit Escape to get back to the regular cursor. And I want to see where the left edge of my board is. So I'm going to double click on it. And then I'm going to remember that my selection filter is only selecting pads. Go back to all items. Double click the left edge, and I note that it's at X31, and the right edge is at X137. So I'm going to double click on the component to set its position numerically, and I could do the math here, or I could have KiCad do it for me. Average 137 plus 31 divided by 2 should give us the point between those two numbers. And we're setting the center of the component, so it should be nicely centered right there. Beautiful. The switch will connect 1 to 2 on both sides. So we're going to double click on this pad and give it a net name. This net doesn't exist yet, so we're going to type it and hit enter, reset. It's the net name that we want to use for this pen. And to actually reset the microprocessor, we connect reset to ground. We don't have a net for that either yet, so we'll type G and D, hit enter. And that's what we want this to connect to. Go back to our C Picro pinout. Over on the right side of the USB port, we can see 1, 2, 3, 4 pins down as a reset pin. That's what we want for our reset net. So find it here, 1, 2, 3, 4. Double click that pad to edit it. Call this reset and connect it to the reset net. There we go. Now I have a little rat's nest line for that. And just above the reset pin is a ground pin. So I'm going to go in and set this to our newly created ground net, like that. We also get a rat's nest line for that, but we're going to do something a little different to connect the ground pins. While we're in here, the other 2 square pins here are also ground, and we're going to connect them all together on our board. Some microcontrollers get grumpy if you don't ground all their ground pins. Some of them are connected internally. Some of them expect you to connect them. I don't know what this one is, so we're going to connect all the ground pins. There we go. Nets are set. We can route our reset net. Actually, before we route, if you remember from the C Picro, let's see which side of the board this is on. We could double click it, but it's more fun to look at the 3D view. And this is an easier way to catch things that just don't look right. So sure enough, we see that our reset pin went on the front side of our board by default, which we could do. There's no reason it wouldn't work there, but I'd rather have it on the back. I'll double click that. In the position, we're going to set side to back, just like that. And we'll see our pads turn blue, meaning they're on the back copper layer. All right, that also means that we want to set the net for this side. I guess there's no reason we can't make longer traces for it. But I'm going to connect this side of the switch. All right, hit X to start a trace, and we'll go from the reset side of the switch to the reset pin. And why not? We'll connect the 2 sides of the switch together. All right, we're not going to connect the ground pin though. We've got a couple different ground pins to connect. And one of the best practices for designing circuit boards is to basically use all of the copper layer of the board as what's called a ground plane. Basically one giant chunk of copper that's all connected to ground. That gets really important when you're dealing with high bandwidth signals, high megahertz clock signals, all kinds of stuff like that, USB data lines. We're not dealing with any of that. This board is about as simple as it gets. Nothing's moving at a high data rate. I don't think a ground plane is going to make a difference, but it's good practice. It's how you deal with electromagnetic interference, basically. So to tell KiCad that we want a ground plane, we're going to go over here on the right side and click Add Filled Zone. With that tool, we're going to click once in the upper left corner, and a wild dialog box appears. This one says non-copper zone though, which is our clue that something went wrong here. We cancel out of that. Sure enough, over on the right, we're still on the edge cuts layer. We don't want a filled zone on the edge cuts layer. We want a filled zone on, we'll start on the front copper layer. So select front copper, click up here in the top left corner again. That looks better. We want a copper zone. We'll select front and back copper zones. And we'll select our ground net here to tell KiCad that we want to connect it to our other ground pins. We'll hit OK, and now we can continue drawing the outline for our filled zone. If you still have Shift Space enabled, it'll be nice and rectangular, but it really doesn't matter as long as it's outside the outline of the board. KiCad is not going to draw copper where there's no copper. You double-click the last point, to complete the outline. There you go. But it doesn't actually fill anything yet. We have to tell KiCad that we want to fill the zone by hitting B. B for fill, I guess. And now we get the characteristic look of circuit boards where everything that's not a trace is connected together, and it's all connected to ground. In fact, if we examine our reset switch, we can see that the ground pin is now connected to the ground plane via these little bridges. Same thing over here on the microcontroller. We've got two ground pins here and a ground pin here, and it's all connected together. Again, this ground plane is not a big deal for a little board like this, but if you were doing something with RGB lights where everything had a ground pin, it's a really easy way to distribute your ground signal across the whole board. And if you're doing anything with high data rates, you're going to need electromagnetic interference protection. When we look at our ground plane, we notice a dark area here where the plane is disconnected, right? It's discontinuous because there's traces in the way, and there was no way to kind of flood fill its way in here. So this area has a ground plane on one side, but not on the other side. We can connect the two ground planes together with what's called a stitching via. It's not going to be a regular route via like we did before, but in the toolbox over here, we can click Add Vias, and then we can click somewhere in this area to stitch the two areas together. And we put one there and one there. Then we hit B and see what it looks like. Yep, that was enough to connect the front and back together and fill in more of our ground plane. Now, if you fill the ground plane and then you still need to work on tracks or footprints or anything else, it gets kind of messy. If we move this out of the way, we'll see that there's holes in the ground plane where it was. Obviously, we can hit B to refill it, but sometimes it's easier just to hide it. And you can do that over on the left here, where it says Draw Zone Fills. We're going to go down to Draw Zone Outlines. And now we're back to the view we had before. One more thing I want to add to this board before we send it off for production is that our diodes here are not actually labeled for the direction they go. And if you're hand soldering your diodes, it's very helpful to know where the stripe is, in other words, which direction it's pointing. These particular diode footprints, if you turn on the front fab or back fab layer, they have a little schematic drawing here on the back fab layer, but that doesn't actually get printed on our circuit board. If we edit the footprint for this diode though, which we can do by selecting it and saying Open in Footprint Editor, we can do whatever we want to the footprint. And what I would like to see is a nice thick line across the silkscreen layer here. So we'll go in here, draw a little box around this thing and delete it. And then we'll select the line tool. And we'll select, if it's not already selected, the front silkscreen layer. And our grid setting is messing us up here, so let's change this down to 0.1 should do it. And we'll draw a line, click here, and we'll hit escape to finish that line. Escape again to go back to the cursor. And I'd like this one to be a little thicker, so I don't need a microscope to see it. So I'm going to double click on it, change this line width to 0.2 millimeters. That looks great. That will make it obvious which way this diode goes. SOD123 diodes have exactly this stripe on one end. Now, if we save this now, KiCad is warning us, editing D4 from the board, saving will update this board only. And sure enough, if we save it, go back to our PCB editor, we have a lovely stripe on D4 and nothing on the other ones. So clearly we need to do something else here. We'll open this in the footprint editor, and we will save it as a new footprint. So it started as the D for diode, SOD123. We're going to add a dash stripe to that, and we need to tell it which library to put it in. You could create a new library for your custom parts, but I'm going to stick it in the Picro library that we already have in this project for our Picro footprints. We'll hit OK there. Saved and updating. We'll close out of that. And now if we come over to one of these SAD diodes without the stripe, we can right-click it, say Change Footprint. We're not just going to change the selected one. We're going to change all footprints with library ID, that. And the new library ID, you think you could just type it here, but you have to actually go library. We'll type -stripe. Click this. And we'll hit change. It'll tell us all the footprints it changed, hit close, and all of our diodes have a lovely stripe on them. Incidentally, that's also easier to see in the 3D board view. We go there. We can see our back silkscreen layer has a nice hefty stripe. Actually, it's a little hard to see under the 3D models, but it's right there. Last thing this board needs is mounting holes. We're going to be mounting this between a top plate and a bottom plate in this little sandwich here. The top plate is what our key switches snap into, so that's an essential structural part. And the bottom plate basically just encloses the circuit board and keeps the parts from scraping up your desk. But to mount the PCB in the sandwich, we're going to need some mounting holes. I'm going to click here on Add Footprint. This will be the last part we add to the board. Type Mount in the search, Mounting. And you get mounting hole. We'll go M2 hardware, 2.2 millimeter hole. Double click that. And we're going to put this hole right on the corner of the board to start with, so we can locate it precisely where we want it to be. If it's not snapping, you can set your grid size back to 1 millimeter here. And click right there, and then hit Escape to get out of Add Footprint. So we're going to drag a box around our mounting hole. Instead of M, we're going to hit Shift M, and we're going to move this -X, 5, and 5Y, like that. Perfect. And we'll hit Control D to make another one, and do the same thing. Shift M, +X, +Y. That one looks a little close, so I think I might rather have these Shift M 4 millimeters in. Let's do the same thing over here, because consistency is the hobgoblin of foolish minds. All right, Control D, and we'll put one down here. Start it on the corner. And Shift M, -4, -4. Perfect. One more. Shift M, +X. All right. If we go to the 3D board view, that is what our board looks like. We have some extraneous silk screens here. We don't really need a reference number for our mounting holes, so let's go to get rid of those. We can click on a legend to select it, and just hit Delete to get rid of it. If you can't select the legend, check your selection filters. I think these count as graphical items or something like that. And while we're in here, we'll also set the reference label for our reset switch. I think if you don't set this, it doesn't show up on the bill of materials, if I remember right. All right, that is starting to look like a completed board. One of the things KiCad can do to help us check to see if this is a completed board is called the Design Rules Checker. So click on this little to-do list here, and we'll click Run DRC. Give that a minute to think, and it comes up with track has unconnected end. Double click on that, it will zoom a little bit and it will draw an arrow. And sure enough, this track is looking very broken. We have a little ghost line here where it should be, and KiCad says, hey, dummy, this is dead end. We'll go back to 0.2 millimeter spacing, hit X, and we will complete that trace where it should be. Go back to Run DRC. You have to hit the icon here, and you have to hit Run DRC again. And it comes up with an unconnected end. I don't know when this happened, but obviously that trace doesn't need to be there. Select it and hit delete. And footprint does not match copy in library. I don't know why this happens when I flip the footprints to the other side of the board, but as far as I can tell, it's innocuous, so you can ignore that. Silkscreen clip by solder mask. Yep, part of the design is going to be cut off by where the solder mask goes. That's fine. So this board's looking pretty good. We run it, and we just have the two flipped footprint errors. If anybody knows why that happens, please let me know. I've made 2 boards with it now and no actual issues, so I'm not sure what I'm doing wrong with flipping the footprint. All right, this is ready to go off to JLCPCB and get manufactured. Make sure you save it. And we'll go to File, Fabrication Outputs. And what we're looking for are called gerbers. Gerbers? I'm not sure. There's a lot of options here. If you go on JLC's page, they say they want use Protel file name extensions. Check that. And subtract solder mask from silkscreen. We'll do that. Just type our output directory. I'm going to call it plot 0. And we will plot this. It runs the DRC at this point if you haven't already. We'll go to generate drill files, so we know where the holes need to be. JLC wants use alternate drill mode here. That probably doesn't matter. We don't have any oval drills. And we will generate drill file and generate map file and close both of those. So if we go back to our project directory, where the KiCad project is, we have a new plot 0 folder. And in that folder, we have a whole bunch of different files that are the standard format for PCB manufacturing. You'll notice that each layer gets a file, back copper, back mask, front copper, etc. And there's also some files to tell it where to drill holes and what the silkscreen looks like. Select all of those and zip them up. That is the file that JLC is going to want. So we'll go over to JLCPCB. And on their front page, you can add a Gerber file. That's what you do here, and find the zip file we just created. Give that a second to think. Upload the files. Process the files, and we're going to get an image of the board here, which should look very much like the 3D viewer in KiCad. You can also pull it up in the Gerber viewer here if you want to see it in more detail, but that looks pretty good to me. It's a 2-layer board. Here's the size. Everything here is defaults. Minimum quantity is 5. If you wanted 70,000 instead, go for that. We're going to stick with 5. Only thing you might want to change is PCB color. There are several colors available. Add some processing time. Does not seem to add any cost, at least for smaller boards. So feel free to pick your favorite color if you can wait a few extra days for it to process. Defaults are great for everything else here. So if you are hand assembling your diodes, go ahead and order that. This one comes out to about $16, $17 shipped. If you want to have a robot assemble your diodes, there's a little switch down here for PCB assembly. Now, it's not quite as easy as just checking this box, but it's pretty close. We'll go ahead and check that box. We don't have any components on the top side. We want to assemble the bottom side. Defaults are fine here. You notice the price went up a little bit. Has not included the components yet, but they won't add a whole lot. Go to the next page. We get into the details of the assembly. So we will confirm that, yes, we are assembling the bottom side. That's where our diodes are. Click Next. And now we need a bill of materials file, and we need a pick and place file. KiCad can generate both of those, but we do need to add one additional component to it. So back in the KiCad main window, click in the Plugin and Content Manager. Give that a second. And in the filter here, we're going to type JLC, because they have their own plugin for KiCad. I already have it installed, but if you needed to install it here, you'd select it, and then you'd click Apply Pending Changes. Go back to the PCB editor, and you'll have a new icon right here labeled Fabrication Toolkit. We'll click on that, and defaults are fine. We'll click Generate, and we get more files. By default, these go in a folder named Production under Keyboard. And we have our positions. Those are the pick and place positions. And we have a bill of materials. This is going to need a little bit of hand editing, so go ahead and open it up in Excel. This file tells JLC which parts get which part numbers. Now you can look up parts on LCSC, or you can use the part numbers that I've already looked up. The diode we want, C81598, and the reset switch, C318884, goes here. Now, KiCad optimistically will put every part in here, but JLC does not have a basic hot swap socket in their library. They do have an extended part, which means you can, I think, mail a reel of hot swap sockets to China, have them put it in their inventory, and then your minimum order quantity is like 450 or something. So it's possible, but we're not going to be having the hot swap sockets installed by pick and place. It would be cool, but they're really easy to solder by hand. So your bill of materials should have 2 rows, one for the diodes, quantity 15, one for the reset switch, unless you want to solder that yourself. All right, save our bill of materials CSV, and we can go back to JLC. We'll find our production folder we were just working on, select the BOM, add CPL file, we'll select positions.csv, and process. It'll read it in. It'll say you want 75 diodes because there's 5 boards, and it'll give you the cost. And here's our reset switch. Everything looks good there, so we'll hit next. And it gives you a little preview of what it's going to look like with the pick and place components. We want to look at the bottom, and we see our diodes sitting right on top of the solder pads. And you see their stripe is lined up nicely with the silkscreen stripe. And there's the reset switch. That all looks good. Now we can save it to the cart. This one comes out to $19.50 plus about $8 in shipping. Pretty good deal if you don't want to solder a whole lot of surface mount diodes. Last thing you need to do is select a category for your product. Some sort of custom thing, I assume. I used office appliance, keyboard. Close enough. Save to cart. And that's it. You'll get a board in the mail with the fiddly surface mount parts already soldered for you. Next time we'll start working on the other parts that make up the case, the plates and the sidewalls.